Hello, and welcome to the skeletal system. I want you guys to meet Bernard. He's our skeleton. He's going to help us learn all about his structures this unit. And I'm excited to talk about the skeletal system. Like, think about it. If you didn't have your bones, you'd be like like a wet sack. You'd just be like on the ground. So our bones kind of give us everything that we need to be able to stand up. And we're going to start by talking about cartilage. So when we're initially born, we're made of like all cartilage and no bone. That's why you have to be so careful with like baby's head. And then over time, most of that cartilage turns into bone, and we just have a little bit left in a few specific places in our adult skeleton. So today we're going to talk about the places where we can still find cartilage. And that's Bernard's friend. He's very excited about the skeletal system as well. So first, there's three different types. You might remember this from our intro unit, but first we're going to talk about like just all the characteristics of skeletal cartilage in general. It's made of cartilage tissue, which if you remember our four tissue types, epithelial, connective, muscle, nervous, which category does cartilage go in? Connective tissue. So cartilage is a type of connective tissue. It consists primarily of water, which makes it really resilient. Like if you have water in a plastic bag, you can like squeeze it this way and like squeeze it that way and like move it all around. So cartilage is something that we can like compress and then it will spring back to its same shape. Like my skin just squishes and bone doesn't squish at all. Cartilage is kind of in between. It's not innervated, there are no nerves, and it's avascular. So remember with connective tissue, there was like a whole range of characteristics. Some of them have blood vessels, some of them don't. Cartilage does not, no nerves, no blood vessels. Surrounded by a membrane called the perichondrium. Peri means around, and that's where it gets all of its nourishment from. So the perichondrium is a different type of connective tissue that does have blood vessels. You will never see very thick cartilage because it has to be thin enough that the nutrients can diffuse from its membrane. And all cartilage has chondrocytes. Cytes means cell. So chondrocyte is just like a fancy way of saying cartilage cell. And they're found in a lacuna. So take a look at this image. The kind of yellow thing right here, that's a cell. The purple part inside of it is the nucleus, that's the chondrocyte. But then notice how it's inside of this kind of like purple thing. That is the lacuna. Because cartilage is hard, the cells can't just like move around. They actually need a space carved out where they can live. So all of this light pink stuff, that's the extracellular matrix, kind of like a watery, jello-y like substance. And then within that, we have the lacuna, and then the chondrocytes are found inside the lacuna. This might look familiar to you. Hopefully it does. Here's hyaline cartilage, just as a real picture of it. We can see the chondrocytes, we can see their nucleus, and then all of that space in between is the matrix, the ECM. Elastic cartilage looks fairly similar, except we see all these like dark purple streaks. Those are elastic fibers. So think about if elastic cartilage is similar to hyaline, but it has more elastic fibers, how might that change its function? And finally, fibrocartilage has less cells, but notice there's like chondrocytes, and then those like kind of light blue things are fibers, and then more chondrocytes and more fibers. So lots of really thick fibers in this one. Okay, to break that down a little bit more and repeat what I said, hyaline cartilage is the most abundant cartilage. You find it pretty much anywhere you have cartilage in your body. And we just saw that the cells are very circular and there's fine collagen fibers. Like if you look at that picture again, you can't even see, or actually let's go back to it. You can't even see any fibers. It just looks like clear. Hyaline actually means glassy, and that's because the fibers are so fine. That means that it's not very strong, but that's okay. It's going to be highly bendable. Hyaline cartilage supports and reinforces, kind of like a cushion would support you when you're sitting down. And like I said, we can find it in most places. Originally, the entire embryonic skeleton is made of hyaline cartilage. So when you're born, you have no bones, you're just hyaline cartilage. And then over time, calcium is added to the hyaline cartilage and it kind of turns into bone. We can also find it at all of the joints. Another word for joint is articulation. I'm not sure if I'm in the camera or not, but like right here is where two bones are rubbing together. That would be an articulation. And so the end of this bone is covered in cartilage to help prevent the bones from like rubbing on each other. Costal cartilages, that's going to be the rib cage. I need to stop sharing my screen so I can make sure that you guys are seeing me for a second. Okay, so just in case that I wasn't in view before, like here's the end of a bone. The ends of both of these bones would be covered in cartilage to help cushion that. The costal cartilages are the cartilages between the ribs. Let's see if you guys can see this. So this is Bernard's sternum, and these are his ribs right here. But in between, there's like a different colored thing, like that's cartilage, 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 cartilage. Think about if our rib cage was all bone, it wouldn't be able to expand when we breathe. But because we have a cartilage attachment right there, it can like expand and then go back down, and expand and then go back down. Where else do we have hyaline cartilage? In our respiratory system. Here's another little head model for you guys. So orient yourself. This is the mouth, that's the tongue. So when we swallow, food goes down here, that's the esophagus. And this is the nose, so we breathe in air and it comes down here to the trachea. So all of this stuff right here in front of the trachea, that would be hyaline cartilage. This kind of triangle structure right there is the epiglottis. We'll talk about that later. But the cartilage on the trachea and the cartilage that makes up the structure of the nose, all of that is hyaline. Now, I wonder, can you see my screen when I go like that? Somebody email me and tell me that. But I'm gonna, I guess, go back to sharing the screen. And make sure we didn't forget any, the embryo, the joints, the ribs, respiratory, and nose. Good. Oh, hyaline cartilage is the same thing as gristle. Like if you are a meat eater, you know that kind of like tough part of bone that like you put it in your mouth and you say ew and spit it out? That is actually hyaline cartilage. So like this would be muscle tissue, the meat that we actually eat. This is probably fat that kind of melts, but cartilage is too strong. It doesn't melt on when you cook it, so you just kind of have to like eat around it. All right, next is elastic cartilage. It's really similar to hyaline cartilage, but it has a way more elastic fibers. Remember that picture of it? It looked like dark strings. That allows it to bend a lot. So for an area that needs to be able to bend more than the other one, we're going with elastic cartilage. Elastic cartilage is found in your ears. If you will take your ears and bend them, like that's pretty impressive. I can't bend my trachea or like some cartilage like that, but the elastic cartilage in my ears maintains the shape of my external ear, but allows it to bend. The other place elastic cartilage is found is in your epiglottis. That is like the thing in your throat that separates your food and your air. If we go back to this guy, that triangle thing right there is the epiglottis. It covers up the trachea when food's coming down, and then it opens it up so you can take in air, and then it would cover it up again. So I always remember elastic cartilage is found in the epiglottis and the ear, like E, E, E. Elastic cartilage, epiglottis, ear. And here we have fibrocartilage, our last type. So it has rows of chondrocytes and then like alternating rows of really thick collagen fibers. That makes it super strong. Like fibrocartilage is basically bone, but slightly more stretchable. It's found in places that are subject to like lots of pressure and stretching, and it's able to compress, like it's able to kind of get smaller when you put weight on it, but then go back to its same size. Examples of that would be the discs in our spine. So let's go back here. These are vertebra. So like your spinal cord would be like right there. And then you have these fibrocartilage discs that separate each vertebra. And think about how, like, when we're standing up all day, like the weight of our body is like compressing our discs down. That's why we need that super strong fibrocartilage. If this was hyaline, or especially if it was elastic, they would just like smash together and then the bones would grind, and that would feel horrible. Another place we have fibrocartilage is in the pubic symphysis. So this is like your hip bones. So let's see, can you see when I put it down here? So like it would be like right here, and like this is my hip bone. And then all of this is bone, except this very front portion right here, the pubic symphysis. Think about, why do we need this part to be cartilage? Women do when they're having babies. This part needs to be able to expand to be able to get the baby out. Can you imagine if that was all bone and we wouldn't be able to enlarge? Also, maybe you've had a torn meniscus. That's like the cartilage in your knee. That's also fibrocartilage. So anywhere where we especially need a lot of strength. This is a nice picture. It shows everything I just said, like all in one picture. Everything blue is hyaline. Notice we see it on all of our joints right there. The green is elastic cartilage, so we can see the ear. We can't see his epiglottis because it's only bone. And then fibrocartilage in red, the pubic symphysis, the intervertebral discs, and the meniscus right there. Please let me know what questions you have. Thanks.